Hey, hi everyone. Welcome to today's Calgary MuleSoft Meetup. Let's wait for around 5 minutes, allowing people to join in. Till then, maybe in the comment section, you can drop from which region of the world you're joining in. Let's wait for another 2 minutes. Okay, I guess we should be good to start. Again, a very warm welcome to today's Calgary MuleSoft Meetup. We were looking forward to host this meetup from quite a while and on a very interesting topic, bridging natural language and databases using Agent Fabric and AI agents. And this is a part of Love Letter to Mule theme. And yeah, again, very excited to present this topic on today's meetup. And coming over to the organizers, I am Ishilveer Singh Randhawa. I work as a solution architect with Caelius Consulting. I'm 7 times MuleSoft certified and 3 times Salesforce certified, and I've worked across various projects across various business domains. Along with me, the Calgary chapter is organized by Bharat Keswan and Neetha Joseph. Bharat works as a technology architect at Infosys, and Neetha is senior MuleSoft developer at PwC Canada. Unfortunately, they were not able to join today's meetup, but Thanks to all of their effort in helping us organize this meetup. And moving over to the speakers, we have two very amazing speakers with us, Sonakshi Mahajan and Pragati Kohli. Over to you, Sonakshi.
Yeah, thanks, Ishilveer. So, hello everyone. Myself, Sonakshi Mahajan. I'm working as a senior solution consultant at Caelius Consulting. I am 2x MuleSoft and 1x Salesforce certified, and I'm really excited to be a part of this as a speaker and looking forward. Over to you, Pragati.
Okay, few housekeeping statements before we proceed forward. A recording of this meetup will be uploaded to the events page within 24 hours. Questions can be submitted or asked at any time in the chat section or question and answer tab. We have put in a lot of effort in organizing this meetup, so let's make it much more interactive. Um, we love feedback, so rate this meetup session by filling the feedback form at the end of the day. It's bread and butter for our meetup and helps us present at a better capacity from here on. The safe harbor statement. So the speakers and the hosts are speaking at this meetup in their individual capacity. We are not representing our companies here. The presentation is strictly meant for learning purposes. Organizers or presenters do not hold any responsibility that the same solution will work for your business requirements as well. The presentation is not meant for any promotional activities. Moving over to the agenda. So lately in MuleSoft, the AI community has been booming, and today we intend to present some components or some features of this AI initiative at this meetup. So we'll start by knowing what's Agentic Sprawl, and then we'll move over to Agentic Fabric basics. We'll move over to MCP and agents, the protocols, including A2A. We'll understand how LLM helps in intent translation from template and result validations. We'll have some very interesting demos from ACB to help us with the above concepts. And finally, moving over to a very interesting quiz. So sit tight. The quiz will include two vouchers to Salesforce and MuleSoft certifications. So listen very carefully and be ready for a very interesting quiz.
Yeah, thanks, Ishilveer. So let us start with the first topic for this session. So the first thing that we need to, we are going to dive into MCP A2A. So the first thing that we need to understand are what are agents and what is agentic sprawl. So we have heard the term AI agents a lot. So an AI agent is basically a software program that acts autonomously on behalf of a user a system. Often it combines reasoning, planning, use of tools, APIs to accomplish certain goals and not just provide us with a static output like text, but it also has the responsibility of performing some actions and tasks and dynamically respond to our in the form of the outputs. So let us think of it in with a real life example. So let's say we have a hospital. So in the hospitals there are they are handling multiple, like hundreds of concerns from various patients on regular basis. So it is very difficult for them also to analyze that which concern is critical, which is not. So in order to make sure that the analysis and everything is done promptly, we can use an AI agent over there. So what an agent will be doing in that case is that whenever a patient comes in with a concern, for example, the concern is that the person is feeling like heartache for like chest pain for the last 2 hours. So what the AI agent will do is it will not only just take up the concern, but it will also analyze it. It will analyze it in such a manner and check whether or not it is a critical issue or a critical concern, and then check whether or not there are any appointments available in the cardiology department, or if there are no slots available, slots are currently occupied, and if is of least lower priority, and then reschedule it. It will not only just analyze those, but it will also perform tasks, like it will work on them. So it will so say reschedule the lower priority appointments and give the priority to the critical concern, and then send out notifications to the patients that their appointments have been changed and what all appointments are there, and also inform the respective teams, the respective health department with regarding the changes of all these appointments. So we can see that in this particular example we can understand that AI agent has not only taken in the perceived the data, ingested the data from the user input, but it has also analyzed it and processed that information to decide what all next actions are to be performed, and then taken up those actions and performed them. So that is how an AI agent works. It ingests data, processes the information, and then performs on it or acts on it. So this is the major uh, way as to how an AI agent works. So now, as we've seen, that AI agents are very self-reliant and they minimize the human intervention, the user input. So many organizations incline to using them into their organizational enterprisal setups and everything. So now, unmanaged and ungoverned, unsecure use of agents can lead to new form of fragmentation, which is called the agent sprawl. So what is an agentic sprawl? Agent sprawl, also known as the AI agent sprawl, is a phenomena that occurs when many autonomous AI agents proliferate in an organization, and they start to act in siloed systems and without any centralized structure, governance, or any kind of oversight. Nobody is managing these multiple AI agents present in the organization. So these can lead to a lot of issues in the organization. The first and the most important risk that needs to be considered is that of the security purpose, because these agents will have access to all of your sensitive data, and if that data is exposed and if these agents are not managed, governed in an appropriate manner, then they will lead to security and compliance risks. Other than that, there is also multiple other issues that there might be a case wherein duplicate or similar AI agents will be created by multiple different teams in the organization, and that those could easily be collaborated, but because of that they have been because of unmanaged and uncollaborative environment, they are created and causes redundancy, cost wage, and other issues could be the scalability. It will be difficult for us to scale those agents and govern them. So that is a major issue. Even though the society in today's day, the technology is enhancing and AI agents are in boost, but we need to take in consideration the agentic sprawl issue that might be caused because of these. So how can we eliminate this issue? So MuleSoft in itself has an agentic landscape that helps us in eliminating the agentic sprawl. So the core of this landscape, the agentic landscape in MuleSoft, is MuleSoft Agent Fabric, which is basically a uniform platform designed to move beyond isolated siloed AI agents, and also allows the organizations to discover and the full capabilities of these AI agents, manage them, orchestrate them, and interact within their ecosystems. So the few of the major components of the MuleSoft agentic landscape are, as I had already mentioned, MuleSoft Agent Fabric, which basically serves as a air traffic controller, or we can think of it as a central agents. It connects silo cohesive network and helps in the management and the governance of these AI agents that we have created. So the agent fabric itself consists of four main pillars. The first one being the agent registry, which is like a catalog based on the Anypoint exchange, which which helps us in the discovery and reusing of these agents, like agents, MCP servers, and LLMs. The second one is the agent broker, which basically orchestrates the business processes and enterprise and interprets what all actions, what our goals are to be performed across all these MCP tools and agents. The third one is the agent governance, that is performed using the Flex Gateway, which we are using in order to apply secured security policies, and in order to make sure that all of these agentic interaction that are taking place in our ecosystem are secured. And the last one is the agent visualizer, which provides us the real-time mapping as to what all agent to agent and agent to system interactions are currently present in our organization. So these are the key components for the MuleSoft Agent Fabric. Other than that, the other key components of this landscape are MCP support, which basically helps the developers to package and leverage the Anypoint platform functionality as MCP tools, and allows us to, interact with AI agents like Cursor and WinSpare without, any with MuleSoft systems using natural languages. The another component is the agent to agent A2A protocol, which basically helps in the agent to agent communication between specialized agents. Like for example, mentioned over here, a credit check agent is can collaborate with a document agent, so it helps in the agent to agent communication. The next one is the MuleSoft Vibes. It is embedded in our Anypoint code builder, and it helps the developers to build agent ready assets, and it includes API specifications, munits, and data view transformations. So the last component of the agentic landscape is the agent scanners. So they are basically the tools that connect to various different AI platforms, for example, Amazon Bedrock, Agent Force, and they are creating they are helping us to discover and catalog these agents automatically into our own organization system, so that we can prevent agent sprawling, and we can leverage the functionalities and features of the other agents that are deployed to other AI platforms. So this is how the agent landscape works. These are the basic components of the agentic landscape that is provided to us by MuleSoft. So now let's discuss in detail that what MuleSoft Agent Fabric is. So MuleSoft Agent Fabric is a platform that delivers the governing, orchestrating, and monitoring of agents across all of those ecosystems, and they can work together securely, intelligently. They can scale together, they can be used to manage. So we can basically manage all of our agentic assets that we are going to use in our agent network, and through MuleSoft Agent Fabric we can govern them and make sure that they are well managed. So MuleSoft Agent Fabric has four main pillars. The first one is the agent registry, which I've already mentioned, that catalog, surface, and reusable. It makes the agentic assets reusable and easy to discover and use across multiple agent networks. Then the another one is the agent orchestration, where in we are able to process multiple agents and multiple systems with intelligent routing. The third one are the agent policies that helps so that every interaction that are and the last one is the agent visualizer, which is used to observe and gain visibility as to what all agent to agent relationships and interactions are currently present in our organization. So now that we have seen what agent fabric is, now let's discuss what an agent network is. So agent network is basically a collection of all of these agents and brokers and LLMs and MCP servers that we are discussing about. So it's a collection of all of those and that are connected to one another, and it acts like a central hub for defining and validating and executing agentic processes across our enterprise. It provides the building blocks for our agentic deployments. It basically creates the entire ecosystem wherein all of our agents, MCP servers, brokers are collaborating with one another in an efficient manner, and we can and are easier to manage further as well. So a few of the key benefits of agent network are that it has simplified the development, because whenever we are creating an agent network, we will be using the Anypoint code builder for that. So we use readable YAML files to create the agent networks, which has further skipped the complex coding and has simplified the development for us. And another key benefit of this is the security and safety and governance, because the built-in guardrails that we have ensure that our agents follow a set of rules and are compliant to what all rules and policies are present for according to our company standards. Then we have the observability, which is basically we can gain insight to what all actions are being taken up by the agents and how are they making these decisions that we are talking about. Then we have the flexibility, that we are able to coordinate between multiple types of agents, tools, regardless of where they are built and deployed. As I already mentioned, that using AI scanners we can, you know, leverage the AI agents and servers that are deployed to other AI platforms. So that proves the benefit of flexibility. And the last one is the tool and agent invocation, which basically means effortless manage of the deterministic, that is the tool based, and probabilistic LLM based actions. So now that we're talking about the agent network, let's see what all components are present in an agent network. So there are three main components of every agent network. The first one is the broker, which could also be thought of as an orchestrator, which basically helps in the high level routing, acts as a high level routing service that manages the task delegation. It acts like a brain of the network and decides which specialized agent or tool are required to fulfill a request based on the A2A standards. The next one is the agent, which is the specialist. Now, as we have already discussed what an agent is, it is an autonomous unit that combines an LLM and has specific goals and has specific tasks to perform rather than just providing us with the static text outputs. And the third one is the MCP server. We will be discussing about it further in the slides as well, but just to give a brief description, it is a standardized gateway that exposes data and tools to the AI and provides consistent interface so that all the LLMs that we have can securely connect with each other, and we can invoke their capabilities without having to integrate custom code for each and every separate MCP server tool. Now let's discuss regarding the agent network architecture. So this is how agent network architecture looks like. It can be divided into three broader sections. The first being the Anypoint exchange. So this of those agentic assets that have been published in our enterprise. So you can see that we have the agent network, agent broker, the agents, the MCP servers. All of those that we have, agentic servers, are present in the Anypoint exchange and can be easily discovered and reused. The second section could be thought of as the deployment section, that is on the Cloud Hub 2 private space. So whenever we are deploying any two agentic assets, the two main things that we have to consider about, that there are two major requirements whenever we are deploying any agentic asset onto Cloud Hub. The first one is the Flex Gateway Ingress, and the another one is the Flex Gateway Egress. We will be discussing about these two as well in the further slides, so I'm going to skip it for now. But moving on to the third major section is the Anypoint monitoring, which basically collects all the logs, matrices, and traces from the Flex Gateway. The runtime manager basically provides an overview of how the applications are performing, and we can observe and monitor all of our agentic assets over here. So now let's move on to the MCP, that is Model Context Protocol, and this will be taken up by Pragati. So over to you, Pragati.
Please feel free to drop down your questions in the Q&A window. We'd be happy to answer them if in case you have any concerns or doubts.
Yeah, thank you, Sonakshi, for explaining, for giving the brief overview of the agents. So, what is the structure of the agents? What is agent fabric and agent landscape? So, let's just jump into the protocols to understand how agents connect to tools and with the other agents. So, if I would say, like many enterprises still want their APIs to be consumable by large language models like Claude, ChatGPT, or Gemini. So this is where MCP comes into picture. So MCP provides a universal way to expose APIs as tools that any LLM can discover and invoke. So what is MCP? So MCP stands for Model Context Protocol, and it is an open source standard developed by Anthropic that acts as a bridge between enterprise system and any LLM or AI application. So we can say that as we have REST protocol for our APIs, we have MCP as a communication standard for our AI applications. So moving on, so if I would give an example for this, so if I would go to Gemini or ChatGPT and say, draft me a message request to send to my manager for booking a meeting room, right? So without MCP, the AI will respond me with a drafted message, but with MCP, it will basically draft and then send that message to the manager as well. So here MCP is one step ahead of our AI, that is not only guessing, but it is actually doing the things for us. So moving on to the MCP architecture. So MCP basically is based on client server architecture, where MCP servers are the interfaces that connect with the external data sources like any database, any file systems, Google Drive, Slack, GitHub. So they basically expose the functionalities that AI applications can utilize. And if I talk about MCP clients, so MCP clients are basically the programs that contains the connections to our MCP servers. So here comes the MCP host as well. So what is an MCP host? So MCP host is any chat application, any code assistant that basically resides the MCP clients. So MCP clients maintains the one-to-one connection to our MCP servers. Coming on to the role of the MCP. So MCP, why MCP matters? So what is the role of MCP? So here in the picture, as you can see, we have three major components. So first is the LLM, second is the MCP, and then we have the various MCP clients that basically we can say as tools as well. We have weather MCP client, then file MCP client, report client, and data client, right? So let's just talk about only the LLMs, right? So LLMs works best when they deal with the static prompts like asking questions, drafting emails, and any random questions that we normally ask to our ChatGPT or Gemini, right? So these are basically stateless in nature and they do not retain any memory, I would say. And when I'm saying they don't retain any memory, so many of you have questions like whenever we ask prompts, write prompts to ChatGPT, they basically respond us with the response that is basically concatenated to our previous response. So what happens is when we work with ChatGPT like applications, so it basically concatenates the response from the previous prompt to the current prompt, right? And if I talk about these various tools that are like weather client, MCP client, the file client, report client. So these are, I would say, these are basically different tools. So LLM can interact with these tools, but how they can interact with, like how LLM would know that which tool they need to call and which tool they need to route that request. So here comes the MCP in the picture. So uh, MCP basically is eliminates the a need for creating any custom code or any logic to see which route the request needs to go, like which dedicated tool or MCP client we need to call. So basically, MCP standardizes the way LLMs interact with the data sources. So we can say without MCP, LLMs suggest the actions, but with MCP, they can perform the actions smartly and even within the context. Now coming on to the next protocol that we have is A2A protocol, that is agent to agent protocol. So A2A is an open standard that standardizes the communication between AI agents. Say for example, different specialists talking directly to each other to complete a certain task. So like here in the picture, suppose a user sends a request asking for planning an international trip for him, right? So here the client agent, or I would say any client chat application or the AI assistant, this it requires to call multiple agents in order to complete that request. Like flight booking, it needs to call flight booking agent, hotel booking agent, currency conversion, and any local tours and travel agent, right? So the problem here is that without A2A, these different agents will not be able to interact with each other as they all can have their different development and different deployments, right? So what A2A as a solution does here is these will be with A2A, these will be able to communicate with each other irrespective of their deployment and development. So the AI assistant, or I would say that here the client agent will act as an orchestrator and it will receive the combined response from all the agents and will represent the response as a single complete travel plan. So moving on to the A2A within our use case. So as you can see, inside this picture, we have a user that will basically interact with our client interface. So the flow will begin with the user that will interact with the client interface. That can be any web app, any chatbot, or any UI, right? So this request then goes to the MuleSoft Agent Broker. So this will act on behalf of the user, and which contains any LLM. Basically, we are using here OpenAI GPT LLM. So next, the request based on the from the agent broker, the request will move to the MuleSoft agent or whether to an MCP. This will be basically handled by the MuleSoft agent broker itself. So once if the request moves to the MuleSoft agent, so what is the MuleSoft agent here? So MuleSoft agent will basically generate the SQL queries and decide whether to which tool we need to call in this within our MCPs, right? It will basically handle the reasoning logic here. Then coming to the MCP servers, so we have two MCP servers here. So one is the database lookup MCP, and next is the notification MCP. So database lookup MCP server is basically exposing the structured tools or for the database interaction, and that is basically connecting securely to our SQL server, and this will execute the database queries on behalf of our MuleSoft agent. And talking about the notification MCP, so this will integrate with SMTP server for the email notifications and with Twilio for the SMS notifications. So this is the use case that we'll be demonstrating in the further part of the session. So moving back to the A2A and MCP. So how MCP and A2A complement each other? So in broader system of AI communication, I would say now we are familiar with both the protocols, like what is MCP and A2A. So I would say MCP's focus is to reduce the complexity that is involved in communication agents with tools and the data, and whereas A2A's focus is to enable interactions between agents so that agents can delegate tasks to another agent. So I would say MCP is for connecting AI to data sources, but agent to agent protocol is enables the agent communication. Moving to the next part, we have the A2A key concepts. So A2A uses a set of core concepts that define how agents interact. So these are basically the building blocks to develop an agent or to integrate with A2A compliant agents, right? So what are the core actors in our A2A? So we have A2A client and we have A2A servers. So what are A2A clients? So A2A clients are basically the agents or the AI agents that acts as on the behalf of the user. This basically initiates the communication using A2A protocols, and A2A server, this basically exposes the HTTP endpoint implementing the A2A protocol. It will receive the request, it will process the task, and it will return the results. So inside the picture that we have shown for our use case, so the MuleSoft agent broker will be acting as a A2A client over there, and our agent will be acting as an A2A server, because that is exposing the HTTP endpoints, right? Now coming on to the communication elements that we have in our A2A. So the very first is the agent card. So agent card basically contains all the metadata of an agent. So it contains the agent's identity, agent's capabilities, endpoints, their skills, any security schemes that we have applied, requirements, basically all the metadata that we have. And we can define within our MuleSoft, we have a configuration for our A2A servers, and within that we can define the agent card details over there. Moving on to the next key concept, we have a task and an artifact. So what is a task is? So task is basically a stateful unit of work that is initiated by an agent through a user request. And every task has its unique task ID to track a task, right? And what is an artifact then? So artifact is basically delivers the concrete results of an agent to ensure the structured outputs, right? So it can be any document or any image, anything. Moving on to the next concept, we have message and paths. So what is a message? So message basically conveys the questions, the context, the answers or updates. So it is a singleton of the communication between a client and an agent, and it contains a content and a role. Role can be anything, a user or an agent, and it contains parts, and parts are basically the fundamental content creator that we can use within our messages and artifacts. And it basically provides the flexibility for agents to exchange various content types within the messages. So we can have different kind of parts. So as you can see in this picture, I have defined parts as kind text. So we can have text part, we can have a file part, we can have data parts, we can have flexibility to change various content types within the messages through parts. Coming on to the next topic, that is the Anypoint Code Builder. So we have discussed theoretically what an agent is and what are the agent networks and what is the protocols involved in connecting these. Let's just come to the practical implementation side of these topics. So starting for that, we need to we have Anypoint Code Builder into picture. So what is an Anypoint Code Builder? So basically it is an IDE for development and implementations. So we can either work locally for desktop on VS Codes or from browser through our Anypoint platforms. So, and it is built from the Anypoint extension pack for our Visual Studio codes. And in order to set up the ACB inside our desktop IDEs, we need to install the Anypoint extension pack into our desktop IDEs, and it further contains the 17 extensions in itself. And once that extension pack is successfully installed, we need to click to the MuleSoft icon that is present over there, and we can then access the different features of the ACP, like create an agent network, then design an API, implement API, develop an integration. So the start will follow the create an agent network in our further demonstrations. So next is the development of the agent networks within our ACB. So how the development is being performed for our agent networks in ACP. So development of agent networks follows a standard software development lifecycle that basically have the 4 main stages. The very first is the environment setup, then project creation and design, then building and publication and deployment. So environment setup is basically deciding a place where we need to deploy our agent network. So once they are being created, we need to have a place where we can deploy our agent network to. Then project creation and design is basically for creating all our agentic assets, and then building and publication is for publishing our agentic assets to our agent registry, and then is deployment for deploying and promoting our agent networks to a given environment. Moving on to this topic, that is usage of LLMs, that is intent translation, prompt templates, and result validation. So how this topic is comes into picture. So we have talked about creation of agents and agent networks, right? So now let's just see how basically behind the scenes reasoning happens, like what is the usage of LLMs between these agents. So talking about the very first term, that is intent translation with LLMs. So if I talk about in Agent Fabric, Agent Broker basically performs the intent translation. So it handles the contextual understanding and it handles the dynamic routing. So what is contextual understanding? Basically, a user provides a natural language request, like unstructured user request is being provided by the user, and LLM then interprets that user's goal and determines which specialized agent it needs to call, like which specialized agent should handle that request, and that is the dynamic routing. Like basically, broker translate that input to a structured payload, and then it routes the request to the targeted tool, like whether it needs to call for example, in our example, whether it needs to call a flight booking agent or a hotel booking agent. So these are the requests will be routed via agent broker. Moving on to the next key term that we have is prompt templates. So what are prompt templates? So prompt templates are structured and reusable configurations that define how the LLM interacts with the data, and this ensures a consistent behavior throughout. So we have to have a connector for this, that is the agent defined prompt template connector, and it uses the AI chain framework, and we used to define instruction templates and datasets within the configuration fields for these connectors. So what are instructions? So basically instructions define the behavior of the agents. Like for example, we need to define within that prompt template connector that as an instruction that you are a helpful customer support agent. So it defines the role and tone of the agent, and then is the template. So template provides the structure for the prompt, like in which format the request will be given, and then is the data set that is basically connects the data to ensure that AI provides us the contextual answers and provide us the accurate answers. The last term, that is the result validation. So result validation, I would say the intent validation, ensures that whatever the response LLMs has generated, it basically, whether it meets our user's goal or user requirements, or it just generating a plausible answers. So we do know that LLMs are probabilistic and they generate the most likely response, and it's not necessary every time that we get a correct or complete one as a response from LLM. So we should always preserve original intent as the structured data, and we should never rely purely on the narrative output. And we should compare final output against the intent baseline, basically what was the user intent initially, and we should introduce retries, clarifications, or logging in any case if any mismatch detects. So to conclude these three terms, I would say that agents bring intelligence and validation brings discipline, but without validation, agent networks are only experiments, and these are not the enterprise systems. Moving on to the topic, agent governance and Flex Gateway. So I would hand over to Sonakshi for explaining these topics.
Yeah. Yep. So thanks, Pragati, for all these insights. So now that we have discussed about MCP agents and A2A protocols and how we are creating agent networks, let's now discuss how we can secure them. So in the agentic network, we govern them through Flex gateways. So let's discuss first what Flex gateways are. So Anypoint Flex Gateway is an ultra-fast, lightweight API gateway that is designed to manage and secure APIs that are running anywhere. So we can think of Flex Gateway as a gateway or a barrier between all of the between our incoming request, the client and the agentic assets in this scenario. But in general, we can think of them as a barrier between the applications as well, and they helps us to enforce policies and manage them and secure them, so that all of these interactions that are going to take place in this ecosystem, they are secured and they are governed as per our company standard. So when we talk about deployments, both Ingress and Egress are required, as I had already mentioned it in one of the previous slides. So what is an Ingress Flex Gateway and what is an Egress Flex Gateway? So an Ingress Flex Gateway, it sits in front of the broker and API endpoints to manage the and enforce policies on the traffic entering the network. So whatever incoming traffic is there for our agentic network, they are going to be managed, and they are going to we are going to enforce the policies through the Ingress Flex Gateway on those. And when we talk about the outbound paths for the brokers, then the Egress Flex Gateway comes into pictures, as it sits on the outbound paths from brokers and agents and any kind of external agents. It enforces the policies, manages connections that and amidst any kind of a telemetry data. One of the key points of Egress Flex Gateway is that it does not have any public endpoint, and it is restricted to clients which are present within the same private space. So whatever traffic is leaving the private space to any kind of external services, it just passes through the Egress Gateway. And it is very important for us to remember that whenever we are deploying any agentic network into our platform, so both Ingress and Egress Flex gateways are required. So now that we have understood about Flex Gateway and their role in the agentic network deployments, let's see what all agent policies are offered to us by MuleSoft. So as we know, policies enforce rules whenever any Flex Gateway processes any kind of requests. The Flex Gateways, when it comes to the agentic deployments, includes A2A and MCP specific policies that provide enhanced securities over the agentic interactions that are going to take place in our organization or our enterprise level. So we have a specific set of policies designed for both MCP and A2A deployments in our Flex Gateway. One more thing that we need to remember is that these Flex Gateways also support the other policies that protect, for example, rate limiting, basic authentication, authorization, threat protection. All of the basic policies that are present for rest of our applications, they are also available to us. But other than that, we have the specific agentic policies present in this with the Flex Gateway. So as you can see in the images, we have separate set of policies. One is for the MCP and the another one is A2A. So in the MCP, we have the first policy is the MCP schema validation, which basically validates each and every request that is going into the MCP server and makes sure that it is compliant to the MCP specification. The second one is the MCP support. It is basically a support to the Flex Gateway MCP server. This is a policy which is required for each and every MCP server deployment. So this is a required policy. Then the third one is the attribute based access control, which is basically provides controls the accesses and permissions for what on the user information basis. So what all users can access, what all tools, it is managed using this policy. Then we have the PII detector, which basically looks for any personal identifier PII data present in the request, and whatever PII data is present in the policy in the request, it looks for that. And then we have the MCP tool mapping, which basically allows remapping of the MCP tool names. The second set of policies in the agentic network is the A2A. So in this one, we have the first A2A prompt decorator, which basically injects the specific kind of data we can add. It basically updates the prompt, and if we have a specific string or something we want to context that we want to inject into the request, we can do that using this policy. Then we have the agent card, which basically rewrites whatever agent card URL to match the public URL of our gateway. Then we have the same two PII detector and schema validation that we had for the MCP. We have the similar policies available to us into the A2A one as well. And then the last one is the token based rate limiting, which basically controls the usage by enforcing token based rate limits. So these are the different kinds of policies that are available to us in the MuleSoft whenever we are deploying any agents into our organization. So now for the demonstration part, I'm going to hand over the controls to Pragati so that she can take up the demo.
Thank you, Sonakshi, for the wonderful explanation. Let me just share my screen. So I hope my screen is visible.
Yes, it is.
Yeah, thank you. So as we have seen the demonstration for the use case that we are going to have. So we basically have a project management system that basically deals with MuleSoft Agent Broker, then MuleSoft Agent, then we have two MCPs into picture that basically interacts with MS SQL Server, then SMTP Server, and Twilio for the notifications, right? So we have a database created for the same, and we have a few tables inside it that is contains employees, that contains the information for the employees, and project assignments that contains the details for the projects, and basically the project assignments. And then we have projects that basically contains the details of the project status, the to which the projects have been assigned, and who is the PM basically, right? So these are the tables and the database that we have created today. And if I move to the very first part of the creation, if we need to have the MCP servers created, and inside our use case we have two MCP servers. One is the notification MCP server, and the other is the project management MCP server, that is basically the database lookup MCP. So going to the notification MCP server, so we have two tool listeners over here. One is for sending the Twilio messages, and the next is for the notifications, right? So going over to the configurations for this MCP server tool listener connector. So we have the basic configuration. So this basically contains, by selecting a connection, so we can have streamable HTTP server that basically streams the HTTP, both HTTP GET and POST, handles both the request. And then we have the SSC server that is basically server sent request for streaming the server events. So we just select the streamable HTTP server for our use case today. And then we need to define a listener configuration, then MCP endpoint, then response content type, and then server name and server version. I have kept the MCP endpoint path and response content type as default, but definitely we can change that as per our needs. So going to the Yep. Going on to the general configuration, so we do need to define the name of our tool, and then we need to define a description for the same. Like in case of this email notification one, I have defined that this MCP tool is used to send email to users, and this should accept the recipient email, subject, and the message content. And the very important part, that is the schema. So this basically define like in which format this tool will accept the request, right? So if I would copy and show you guys like what actual schema is, right? So this is the schema that I have defined inside my email notification MCP server. So here I have defined schema. So as you see, our every AI communication is basically on the JSON RPC thing. So we need to define the schema, and then we have to define the title. I have defined as an email, and description for this tool, then type is object, and the properties, like which properties it accepts. Like for email it accepts two, then subject, then body, and which type of which is the what is the type of that property, and the description, the format, and these are basically the parameters, right? And then I can also define out of which properties which are required and which are basically the additional properties. So we can define these things into our schema for the tools. So next we have the responses that we can set as, and I have set as a content, text, and payload raw that we need to define inside the responses. So if I move to the send value MCP configuration, so here I have defined the description that it is used to send the SMS to the phone numbers, and it should accept a message and phone. And schema, so basically schema is very specific to every tool and changes with the tools itself. So for the this we have changed the schema, and we have defined different properties that basically this tool listener will accept. So it will accept a phone and a message, and which properties are required, we defined as phone and message. So these two things are required within this tool listener, right? So schemas are basically very specific to the tools, and then inside the responses I have defined payload raw. So this is about the configuration details for the MCP server tool listener connector, and rest of the implementation is as we do in our normal API implementation. So rest is the same. I am just calling the Twilio REST API for sending the SMS to the registered mobile numbers, and then email for the email notification. I am utilizing the SMTP server for sending out the email notifications. So this is the one MCP that we have for sending out the notifications. And next is the project management MCP server that basically handles all the database operations. Like the very first tool that we have is that basically executes the generic SQL queries, like it fetches the records from the database. Then we have another tool for getting the tables list, like what all tables are present inside our database. And then we have the tables for fetching the table schema. Then we have another tool for getting the column values, right? So we have these tool defined, and as mentioned, every tool has its own schema, and we need to define the schema for every tool according to the properties that they should accept. So these are the tools in the project management MCP server. So both of these servers are deployed in our private space. So let me just go and show you the request, like to these MCP servers. So yeah, if you create a new request for the MCP, so we have two options over here. We can either select the standard in STDIO, that is basically the standard input and output for the local servers, and then we have the HTTP option over here. So I have created a request by selecting the HTTP, and then I have pasted the URL over here that we get after deploying these MCP to our private spaces. And once that the connection is being made to this MCP, you will be able to see what all tools these MCP basically exposes. So in case of our notification, we have two tools. The very first is the send email, and next is the send SMS. So whatever the description that we have provided into our configuration, so you will be able to see over here, and what all parameters it accepts. So it accepts to subject and body. So everything, whenever you whichever tool you select over here, this will basically shows us the description and the properties that it requires. Like in case of send SMS, it requires a phone and a message based on our schema that we have defined inside our tool. So I would just show the functioning of this send email one. So when I click on this send email, so as you can see, there are some arguments that needs to be passed. These are basically the properties that are defined in the our schema, and inside this we have two subject and body. So inside two, I am just passing a recipient, and in the subject that this is a sample test MCP email, I would write here, and then hi, this is a test email from MCP server as a body. So let me just send a request. Yeah, so as you can see, it responded that email has been sent successfully. So let me just move to my inbox and see if whether I have received the email. Yep. So as you can see, I have received an email saying this is a sample test MCP email, and it contains the body that I have provided inside my request. So this is how our notification MCP server is working. And similarly for the DB, once the connection is being made, you'll be able to see all the tools that have been implemented into our MCP server. Next comes is the agent. Next comes is our agent server. So we have one MuleSoft agent that internally uses our project management MCP server. And so this is basically our project management agent server. So this contains the entry point of this agent server is the A2A task listener basically. So this makes our agent A2A compliant. And what all are the configuration details for this? So let's just look at the basic first. So for inside this, we need to define a listener configuration, then the agent path, then the card. So as you remember, we have discussed in the key concepts for A2A, like we need to have an agent card. So we define the agent name, basically every all the metadata of the agents, right? We define the agent name, agent URL, the version, the description, what all skills our agent has, then the security and the security scheme. So we can basically define every detail of the agent inside our agent card. So this is basically the beta version of our connector that we are being using for our demo. But definitely for the connector version, we do need to have an agent card.json file that basically contains every metadata of our agent, and we need to refer that inside our agent card reference over here. So this has been reported. So we have reported a bug to the MuleSoft support for this lab. But once that has been resolved, we do need to define the agent card.json file containing all the metadata of the agent. So this is about the A2A task listener configuration. Then we have the response headers, error response, and response header. So this is basically the same as we have for the HTTP listeners, right? And moving on to the next, we have the retrieve context subflow. So this is basically for the contextual retrieval. So basically what it does is it retrieves the context ID. So whenever request has been sent to an agent, so it looks for the context ID. If any context ID is present, so it will fetch the memory that has been stored inside our object store and continuously request based on that context ID. But if no context ID is being fetched, so it will generate a new session. And then we are setting the initial parameters, the task ID, context ID, the message ID that we have discussed in the key concepts of A2A. Then comes the planning flow. So this is the core intelligence layer of our agent. Coming on to the planning flow, so basically first it lists all the tables via the MCP tool that we have defined in our project management MCP server. So once it lists all the tables that are being there in our database, then it fetches the schema based on that table. So once the table schema has been fetched via MCP tools, we go for we have plan inspection, that is the defined prompt template connector over here. So what it does is basically based on the user query and database schema, it identifies which columns, if there are any, that needs that requires the that needs to be inspected to find the valid values. Basically here it is basically validating like which values or which columns we do need to fetch additionally. And then once that has been done, we move on to getting the column values from the table. And once the column values have been fetched by the tool, we generate the SQL. From our natural language. So this will basically convert the natural language question that has been asked to the agent to a valid SQL query that will be performed as our database operation. So once that has been generated, we once that is being generated, we fetch the table records by executing that query via our tool. And once we do have another scenario for this, but let's just come to the success scenario. So once that records have been fetched successfully, we just summarize that response into a natural language response. And if there are no records found, or if there are no records that has been fetched, so we should say that there are no records. So basically this defined prompt template over here summarizes the response into a natural language response, and then we are updating the memory and storing the context for the contextual retrieval. Now coming on to the next another scenario that we do have here, like in case of any errors, basically the result validation parts come over here. So in case of any errors, so suppose our query fails, or in SQL query that has been created contains any SQL syntax error, or it is generating an error. So we do have a query correction flow subflow for this. So we are basically sending the error, and we are basically sending the error and the SQL query to our inside this, and then we are sending this incorrect SQL query basically to fix the SQL syntax. And once that has been corrected, the SQL has been corrected, we are going to retry that query via our tool and see if the query succeeds. We are just summarizing that response and sending back to the user. But if it fails, so we just have the recursion and it retries up to 3 times. And if it fails after retrying 3 times, and if our retry succeeded, we just our flow just comes out of recursion, and we just actually get the final error, and we respond back with the error to the user. So this was about our planning flow, and once that has been executed, we prepare the agent response and sends back to the user. So this was about the implementation side for the project management agent server. And if I go to the the agent calls, so the very first is getting the agent card. So once we hit this request, we get the metadata of the agent. So basically the agent card, the metadata that we have defined inside our agents. So the agent card can be retrieved from this request. And next is the post agent call out. So basically this basically handles the detects the as in the user that is sending the queries to the agent to see what response we get. So it should be sent inside in this format. And as you can see inside message, we have the kind, like what kind of message it is and what is the role, like whether it is a user or an agent. And then we have message ID and context ID for the context retrieval. And then the parts, like what kind of message, basically what content type we are sending. So it says it is a kind text, and we are sending the text to our agent to see whether it gives the response or not. So let me just remove this context ID for now and start with the new session. So let me just, so as I've already shown you, let me just query the projects. So these are all the projects that are there inside our projects table. So let's just query. Inside the status, we do have a single project with a status as pipeline. So let's just see if our agent responds us with the correct project name via the natural language request. So let's see which project is in pipeline. So let me just send this to my agent and see if it responds us with correct answer. Yep. So it comes that the project currently that is in pipeline is AI Copilot integration. So let me just see. Yeah. So this is the project that has the status as pipeline. So it has given us the correct response. So let's just see the context ID functionality. So let me just copy this context ID and paste over here and ask another question related to this to see who is the PM of this project, right? And let me just see the value. So the PM ID that is associated, it is E006. Okay. Let me just send the request. So yeah, it says that PM of this project is Pragati. Let me just, so the PM ID is E006. So let me just query employees and see who is E006. So as you see, E006 is Pragati, and it has generated a correct output for us. So this is the working of the agent with the context retrieval or without it, right? So we have discussed the major components like MCP servers, and we have also discussed the agent, like how it is utilizing our MCP servers and calling out the tools that are being exposed via MCP. So we do have a agent broker into picture to showcase how A2A comes into this setup. So I would hand over the A2A demonstration to Sonakshi. So
Thanks, Pragati. So now let's move ahead with the final piece of the session, the demo. So now we have seen how we can create. I hope my screen is visible. So yeah. So
Yes.
okay. So now we have seen how we can create MCP servers, agents, and now let's see how we can combine all of them together in an agent network. So whenever we are to create a agent network, we will be using the Anypoint code builder. So in order to create a new project, so this is the project we have created for our use case, but I'll just show you the steps as to how we can create a new project. So in for all the Mac users, the commands are Command Shift P, and you'll see this search bar where you can see search for create, and here you'll see the option create an agent network project. For all the Windows one, just Windows users, just replace the command key with the control key. So just we'll click on that. Herein we will provide the name of our project, the location in the, like basically the workspace, the business group. So one thing that we need to ensure is that our Anypoint code builder in our Anypoint code builder, we have have our Anypoint platform signed in. So once that is done, you will be able to see those business groups. We'll be selecting the business group and then click on the create project, and your project will be. So this is how you create. And whenever a new project is created, there are these files that comes up. The first one is the agent network.yaml, and the second one is the exchange.json. The agent network.yaml consists of all the components, the structure of all the components that are being used, the broker, the MCP servers, the agents, the LLM providers, and the connection to those. All the details and all the connections are created in this file. And as for the exchange.json file, it has the metadata of the agent network, and it will be visible to us whenever we will be publishing it to the exchange. And also it has variables. So variables basically have the values that we do not want. For example, the URLs of the LLM and the agents and the MCP servers, we do not want to hard code them into our agent network file when we are making the connections. So we are going to basically like an externalization. So we are going to externalize them into these variable sections. So let's go one by one into the each section. And whenever we create a new project, there is also this visual representation of the agentic network for us. Here you have the agent network name, which we have defined as the project management agent network. Then we have the broker, the agents, and MCP servers. So in this part, the brokers, we will see all the brokers that are mentioned or created in this specific YAML file that we have declared in this YAML file. And the agents and MCP server section will also have all the agents and MCP servers that we have added into the local YAML file. But the agents and MCP servers inside the particular broker section will be of those that are connected to this particular broker, that have a link to this specific broker, which will be leveraged by this broker. So those specific agents and MCP servers will be present in this section. Also, you can see the LLM that we are using, the LLM provider, which is the GPT-5 Nano. So that will be specified in the broker section over here. So the YAML file has these key components. The first one being the label, wherein we have mentioned the name of our agent network. Then in the broker section, we have the brokers. So we can create multiple brokers. For the demo purpose, we have created the project broker. So all these different brokers will be present over here. Inside each broker, we have two other sections. The first one being the card, which is similar, which is the agent card, which we have discussed in the previous slides, which Pragati explained. And the another one is the spec. So the card section will have the protocol version, the protocol that it is the protocol version that it follows. Then we have the name of the broker, that is the project broker, the description as to what the description of this specific broker is, which is to route natural language requests between our SQL DB and communication system. Then we have the URL. So now you can see that the URL is not hard coded in the agent network file, but in we have a placeholder for that, and the URL will be I'll be showing that in the exchange.json file. So then we have the capabilities section, what all capabilities are there for this broker. Then we have the version of the broker, the default input modes, what kind of metadata, what kind of media type it accepts data, and the output mode, the skills of this. So in the skill section, you will see that there are two separate skills. The first one is the project intelligence skill, which will be using the agent in itself, and the second one is the stakeholder notification skill, which will be leveraging the MCP servers. So each and every skill will further have, we have the description for the same. We can set up some examples, the that of the broker, the tags, and any ID. The next ID shows the notification scale with the name, description, the examples, and the input modes, output modes, and any tags that we want to assign with them. So this was all that was present in the card section of every broker. And when we move ahead to the spec section, so we have all the specifications that have been added to this broker that will be connected to the broker. So you can see there are three separate fields, so sections. The first one is the LLM, where we are going to mention and refer the LLM that is going to be used, and the LLM is provider over here. So you can see the reference is that of an open AI, and in the LLM provider section over here we have the same name. So that means this LLM is now being referenced into this specific broker. And similar to that, we have the spec for the instructions and the spec for the agents. We have the reference to the project management agent. So if I'll show you the agent section wherein we have referenced, so you can see that the project management agent is now being referenced by this specific broker. The similar will be taking place for the tools. In the tools we have the MCP. So MCP communication MCP is being referenced over here, and in the MCP section we have the metadata for this and the label and everything. So this is how different sections are present in our agent network.yaml file, and each and every section has its own purpose. These sections provide us the details and specifications, and in the broker section we refer to these agents and LLM providers and all of our MCP server tools. The last section is that of the connections. So here we are establishing the connection. So this is the agent connection, this is the MCP server connection, this is the LLM connection, my OpenAI connection. So in this one we have the kind, we are mentioning what kind of connection it is. It is an agent connection. We are referencing it to again back to the agent, project management agent, and then in the spec we are mentioning the URL which has a placeholder which will be mentioned in the exchange.json file. In similar way we will be setting up the connections for the MCP servers and the API key for our LLM provider as well. So the URLs will be, as you can see, we have placeholders for that. So these URLs are present over here in the variable section of our exchange.json file. As I've already mentioned, it consists of the metadata. In the variables, you can see that in the project agent, we have the default URL for the agent. Then we have, if we want to keep it as a secret or not, because it's a URL, we are keeping it as a false. Then for the MCP one, we have the description, the URL, and the secret option. Then for the OpenAI, we are having the API key, we are mentioning the name, and as it is a key, we are going to keep it as a secret. So this is how an agent network is created in Anypoint Code Builder, and how we are going to, these are the two main files that are required. So now that we have seen how it will be created and what all are the components of the agent network, let's see how we can deploy them. So the first step we are going to do is we are going to set up the flex gateways. So we can directly create flex gateways, the Ingress and Egress flex gateways from the code builder itself. Again, I'm going to go and search for Command Shift P, and then we are going to search for setup. So here you can see setup agent network. Once you click on it, select the business group. So I'm going to select the business group, then the environment, and then after that the private space. And once you'll select enter, it is going to start with the deployment, and it is going to create the two flex gateways for us in our runtime manager. So I'm not going to deploy them right now, because as we all know, the time has exceeded a little bit. So in order to make sure that the steps have been shown, and we have already deployed the flex gateways beforehand, so we will be showing those. So this is how you deploy the flex gateways. Let me go back and log into my platform. Now if we'll go into the runtime manager, and in the flex gateway section, we can see the Ingress and Egress flex gateways have already been deployed and in the running status. So this is how you deploy the flex setups, flex gateways. And after that, we are going to publish our agent network to Exchange. So for that, we will search for publish. Then we will click on the publish agent network. Once you click on that, you will get these options wherein you have to mention the asset version. Since we have already deployed it, so we are seeing the current version, then the project metadata with the asset name, asset ID, business group, and just click on publish, and you'll be able to discover and use it from your Anypoint exchange. In the similar manner, after you have published it, we are going to deploy it. So now I'm going to search for deploy, just click on it. Yeah, so here we have to select the environment. We will be selecting the sandbox environment. As you can see, these got auto populated. The private space, the ingress gateway, egress gateway, these were auto populated as soon as I selected the environment. And then we have the variables. As you can see that we have the agent URL, the MCP server URL, the open AI API key over here, and the project metadata. And just you have to click on deploy, and then your agent broker will be deployed to runtime manager. Again, we have deployed it to yes, so this is the agent network and the broker has been deployed. So now I'm going to yes, so we are going to see how we can leverage both the agent skills and the MCP server skills from the broker. So first I'm just going to request the agent card. So just we can see the what all description, the skills, whatever we added into our agent network YAML, they are all visible over here. Now in the broker call out, I'm going to first make the call to check the name of the PM working on the project in pipeline right now. So I'm just going to send in the request. It sometimes take some time. Yep. So we can see the project manager and the email and project in pipeline is Kohli. And now I am going to use this email address and send an email to it. So I'm just going to send in the email and just click on send. Till the time it's making the request and receiving the response, we can look into the policies. So we'll be seeing how we can apply policies as well in the agents and tools section. You have to go to the API manager. Let's see. Yep, so the email has been sent, and now I'm just going to apply a policy just to show how policies work on the project broker. Just click on the policies, add inbound policy, and we can go into the A2A section. And let's say we add the A2 API detector, click on next, add, let me add it on email, reject it, and then apply. So now the policy has been applied. It will take a minute or so. Let's make a call, because now we are making the same request and sending the same request with the email ID. It should not let it go through. Okay, the policy has not been applied. Let's just wait a minute. So here we have 401 unauthorized, and since it had the email mentioned in the request, so we added the policy and it rejected the request. So this is how the agent network is created, published, deployed. We set up flex gateways, and yeah, so that's it from my end. So let's move ahead with the quiz.
Yeah, but before the quiz, I would like to request everyone to switch on their cameras. I'll assign presenter mode permissions to everyone. We'd like to switch on cameras to have a picture so that we have captured the moment and maybe we can float it on the social network then. Let me assign everyone permissions one by one. Just another moment. Last few. Yeah, I'll again request everyone to switch on their cameras. Let's have a picture of all of us. Aman, Suman, Veteshwari, Sindar, Yunzu, Samrid. Okay. So yeah. Thank you everyone. And now the wait for the moment is over. Let's have a very interesting quiz. And as you all guys remember, we have two MuleSoft vouchers. Sorry, Salesforce vouchers that can be applied on Salesforce as well as MuleSoft certifications. I'll quickly share the screen and all of you can go to kahoot.it. I'll give a game pin that you can enter and you can then therefore contest the quiz. Okay, you can let me know when the screen becomes visible. Yeah. So the pin is 80303. Let's wait for another minute. Okay, respecting everyone's time, I guess we should be good to start. You excited for this quiz? Okay, let's see. So some of you are not that much excited. So the first question for the quiz: what architectural characteristics distinguishes an autonomous AI from a conventional text generation LLM? Okay, let's see the answers. So it's Aman Sharma, Karthik, and Ankit on top. Moving on to the next one. Why does Agentic Sprawl introduce enterprise security and compliance risk? So 10 people have answered it in a wrong manner, 8 are correct. Let's see. So Karthik Sharma climbs to the top, followed by Aman, Samrit, NG, Rajasekhar. Moving on to the next question. Which capabilities reduces agent sprawl by discovering, registering, and cataloging agents deployed in different AI ecosystems? MuleSoft vibes, agent registry, agent scanner, agent to agent protocol. Okay, so only 3 people have answered it correctly. Let's see. Karthik Sharma, Aman Sharma, Samrid, NG, and Rajasekhar. So next question. Full form of MCP is model context propagation, model concern protocol, model context partition, model context protocol. Let's see. People remain the same, followed by NG, Rajasekhar, and Manya. Let's go to the next question. Under A2A interoperability standard, which component dynamically determines intended agent for request? Router, API kit, broker, or we send the target agent and request itself? Let's see. So again, the first 2 winners remain the same, followed by Rajasekhar, Manya, and Ankit. So you need to type your answer now, which has a double points for the effort, which is the latest A2A protocol version. You got 20 seconds to do so. So only 2 people have answered it correctly. Wow, that's very interesting. Actually, the agent network YAML had highlighted it, but let's see who those 2 people are. Oh, so Karthik Sharma and Aman Sharma are on top. The leaderboard essentially remains the same. Moving on to the next question. In agent network, which component enforces security policies on inbound traffic before requests reach the broker? Ingress Flex Gateway, Firewall, Private Space, or Egress Flex Gateway? So the correct answer is Ingress Flex Gateway. But the leaderboard remains the same. Let's move on to the next question. That's multi-select one. What helps us to create agent network project? ACB, ABC, MuleSoft Vibes, Anypoint Studio. So let's see what the leaderboard shows. Okay, Granch and Anya climb up to the 4th and 5th position respectively. Moving on to the next question. True or false? MuleSoft Agent Fabric can only have one broker. Agent network, sorry. So let's see the leaderboard. So Swapnil climbs up to the 5th position, and the last question for the day. That's a multi-select one too. We can apply policies on what all assets using Anypoint Platform. MCP, agents, API, agent brokers. So remember, this is a multi-select question. So actually all answers were correct. Let's see who are the top 3 contenders over here for the coupons. Swapnil is 3rd, Aman Sharma is 2nd, and Karthik is 1st. So congratulations to all the winners and to the runner-ups as well, Gurans and Manya. So yeah, thank you everyone for attending today's meetup. Your presence is highly appreciated. Please do rate our meetup on the meetup channel page, and looking forward to see you all again. The video of the meetup would be available on the Caelius Consulting YouTube channel, and the code as requested by many participants would be uploaded to the GitHub repo, which I gave a link to in the chat section. So thanks everyone.